We've now discussed all of the factoring steps. So to summarize, we begin by writing a polynomial in standard form. Then we factor out any greatest common factors that we have, making sure the leading term is positive. Finally, count the number of terms. You're either going to have 2 terms, 3 terms, or 4 terms. In order to factor 2 terms of binomial, check to see if one of these 3 methods will work. If one of these 3 methods do not work, it cannot be factored. For factoring a trinomial, you want to look at A, the leading coefficient, see if it's equal to 1 or if it's not equal to 1. If it's equal to 1, you can factor it directly into 2 binomials. If it's not equal to 1, we're going to split up that middle term, giving us a polynomial with 4 terms, allowing us to use the grouping method. Once you've factored, look at your factors and see if you can factor any further. And then finally check yourself by multiplying back through, making sure you come up with the original polynomial. So example 1, we're in standard form. We do have a greatest common factor of 2. We factor it out. We're left with x squared plus x plus 2. Still a trinomial now inside the set of parentheses, more specifically a trinomial where a is equal to 1. So we begin by listing the factors of the constant 2. Well, we only have 2 factors, 1 and 2, and it looks like it would work. They give us that middle term of 1 or 1x. So we set it up. X and x in the first binomial is 1 and 2. Second term in the binomials, and the signs must be plus and plus. However, when you check yourself here, FOIL back through, it gives us x squared plus 3x plus 2, which obviously is not what we want, so it does not check out. So we're done at this point. It would not be considered prime, this problem, because factoring out a greatest common factor is factoring. Prime means you cannot do any factoring whatsoever. So once we factored out a greatest common factor, we're done. That's all the factoring we can do. Example 2, as we know, typically we begin by putting them in standard form. This one obviously is not, but the author of this textbook does not want you to put binomials in standard form. So we're going to factor it the way it is. We do not have a greatest common factor, so we look at the terms, see if they're perfect squares, perfect cubes, or neither one. Obviously 9 is a perfect square, the square root is 3. 16 y squared is a perfect square, the square root is 4y, and we have subtraction. So difference of squares, 3 plus 4y, 3 minus 4y. Example 3. Basically it's in standard form. We do not have a greatest common factor. So count the number of terms, 4 terms. Factor using the grouping method. The first set of parentheses, factor out an x, we're left with 4a minus b. The next set of parentheses, factor out a y, we're left with 4a minus b. So 4a minus b, factor out that common factor, what we're left with then, x plus y. Example 4, standard form, no greatest common factor, 2 terms that are both perfect squares, y and 8. But the sign, addition. There's no such rule as a sum of squares, so it cannot be factored. It's prime. Number 5. 6x squared minus x minus 16. It's in standard form. No greatest common factor. Count the number of terms. We have 3 terms, a trinomial where a is not equal to 1. So we begin by multiplying a times c together. 6 times 16 gives us 96. And list the factors in 96. 1 and 96, 2 and 48, 3 and 32, 6 and 16, 8 and 12. And we need to choose the pair of factors that we can combine and get the middle term. So obviously none of them get added or especially subtracted and get that middle term 1. So if none of them work, it's prime as well. Number 6. Begin by writing this in standard form. 6q to the 5th plus 3q squared plus 9q. Greatest common factor, 3q. We're left with 2q to the 4th plus q plus 3. Still have a trinomial inside the set of parentheses, but it cannot be factored any further. So at this point we're done. It's completely factored. Number 7, 5a squared plus 15a. It's in standard form. We do have a greatest common factor, 5a. We factor it out. It leaves us 5a times x squared plus 3. Still a binomial where the first term's a perfect square, but the second term 3 is not, so it cannot be factored any further. Once again, we're done at this point. It's completely factored. Example 8. It's in standard form. We do have a greatest common factor of 2. We factor it out, and once we factor out the greatest common factor here, both terms become perfect cubes. The cube root of x cubed is x, the cube root of 27 is 3, and they're being added, so we're going to use the rule sum of cubes. So substitute these values, these perfect cubes, into the formula for sum of cubes. The binomial becomes x plus 3 times the trinomial x squared minus 3x plus 9. Don't forget to carry down your greatest common factor of 2. So we're completely factored, have a total of 1, 2, 3 factors, 3 things being multiplied.